Hello there! Today we're going to take a look at fractions on a number line. As per your request, a lot of you said I'd like more practice putting fractions on a number line and then seeing where those equivalent fractions are. So today we're going to practice that together. And the first thing we're going to do is I'm going to give you a number line with some endpoints. We're going to have fractions that are greater than 1 whole. So are you ready for that? Okay, following along on your own board, I want you to draw a number line and with endpoints 0 and 2. Are we missing any whole numbers or integers between that? If I'm counting from 0 by ones, what do I have between 0 and 2? I've got 1, 0, 1, 2. So I need to make sure I add in that number. 0, 1, 2. Doing my best to equally partition those. Now I'm going to look at what unit I'm going to be partitioning by. Thirds. If I have thirds, what's my unit fraction? What would that look like? Remember, a unit fraction has 1 in the numerator, so I would have 1/3. So every time I count, I'm going to be counting by thirds. So when I'm doing thirds, I need to divide each whole into thirds. I have 2 wholes here. So in my first whole, I'm going to divide it in thirds, just by drawing 2 lines because I have 3 parts. And my second whole, I will partition it in thirds. So now I have thirds on that whole and thirds in that whole. Now I need to figure out, I know my denominator will be 3 all the way across because I'm counting by what? Thirds. Thirds. Excellent. If I have 0 here, how many thirds is that equivalent to? 0. Now counting up by 1/3, I have 1/3, 2/3, 3/3. Oh, excellent, because I know 3/3 is equivalent to 1 whole, 4/3, 5/3, and 6/3. Great, because I know 6/3 is equivalent to 2 wholes. Remember, I can show fractions in many different forms. I could show a fraction on a number line. I could show it with a picture here. Excellent. So if I asked you to identify where is 4/3 on your number line, you'd be able to tell me 4/3 is right here. Or I could say, where is 2/3 on your number line? Here. Excellent. So there is a way to show that with thirds. Let's try this again, but this time with sevenths. So I'm going to go ahead and erase my board. Sevenths. Same thing, we're going to have endpoints of 0 and 2. So what was the first step we did last time? And I'll write down here, sevenths. Our unit fraction is 1/7. And to draw that pictorially, it's going to be kind of like a person. 1, 2, 3, 4, 5, 6, 7. Great. It's like the person's legs with extra 2 arms and a set of legs. They're my sevenths. Okay. Anyway, we have 0 to 2. Which number am I missing in between there? I'm missing 1. Oops, not quite equally partitioned. Let's try to equally partition 1. Excellent. Now, what's our next step? We need to partition each whole into sevenths. This isn't my whole is right here, and then I have a second whole there. And when I'm saying that whole, I mean this one, not like a hole in the ground, an entero, whole. So on my first whole, I'm going to partition that into sevenths. So I need 6 lines. 1, 2, 3, 4, 5, 2, 3, 5, 6. So do I have 7 parts in this one? 1, 2, 3, 4, 5, 6, 7. Excellent. Now I have partitioned each of my holes into sevenths. Now I need to figure out what's my denominator. I know it's going to be sevenths. So I can go ahead and put in my denominator. Whew, lots of sevenths here. It's good we're not doing hundredths. Excellent. Let's go ahead and fill in our really important ones. So I know 0 is going to be 0. If I have one whole, how many sevenths will I have? I'll have 7. And if I have 2 wholes, how many sevenths? I'll have 14. Remember, the relationship between my denominator and my numerator, well, if I have 2 wholes, I can multiply 2 by 7 to get 14, right? Now I want you to fill in the rest of the sevenths. 1, 2, 3, 4, 5, 6, 7. 12, 13 sevenths. So on your number line, identify where, actually I want you to find a fraction that is between 1 and 2. What is a fraction that is between 1 and 2? You could have any of these, so I'm going to choose 10 sevenths. And I could write an inequality. 10 sevenths is greater than 1. Or 10 sevenths is less than 2. Now I want you to choose a fraction that is between 0 and 1. What's a fraction that's between 0 and 1? Maybe 6 sevenths. 6 sevenths is greater than 0. 6 sevenths is less than 1. And I know that because 1 is equivalent to 7 sevenths. And that's true. 6 sevenths is less than 7 sevenths. Great job. So now we're going to look at how a number line could help us find or identify equivalent fractions. So we're going to do that with thirds and sixths. Remember, in our other video that I made, we used a tape diagram to show we had thirds. And then how did we go to sixths? We partitioned each of those in half. And then we said 1/3 was equivalent to 2/6, for example. Okay, how could we show this on a number line? We're going to use our thirds and our sixths to show that. So we're going to start again with our endpoints, and we're going to go from 0 to 2. So here's 0, 2. And I know I need 1 in between. So I'm going to compare thirds and sixths. One way to do this would be to draw 2 number lines, but since thirds and sixths are related, because sixths, there are two sixths for every third, I'm going to do it on the same number line. So on the top, I'm going to start with my thirds. So we already partitioned, we know how to do this. And label them. 3/3, 4/3, 5/3. Oops, I'm already thinking about sixths. 6/3. Excellent. Now, how am I going to get to sixths? If I have sixths, what and how many parts am I partitioning each hole? In 6 parts, correct? But just like on our tape diagram, we knew that if I partition each third in half, I'm going to get sixths. So I'm going to go ahead and do that. On each of these, I'm going to partition. So in this first whole, do I have 6 parts? 1, 2, 3, 4, 5, 6. Yes. And here, I also have equal parts, 6 equal parts. Now I'm ready to label my sixths. Be careful, some of you made errors here and not labeling each part. So here I have 0 sixths. At 1, how many sixths will I have? I'm going to have 6 sixths. I know that makes a whole. And if I have 2 wholes, I'll have 12 sixths because 6 times 2 is 12. Okay, those are my anchor ones that I filled in first. Now I'm ready to go fill in 1 sixth. A lot of you skipped this third, but I know that 1/3 is equivalent to 2 sixths, 3 sixths, 4 sixths, 5 sixths, 6 sixths, 7 sixths, 8 sixths, 9 sixths, 10 sixths, 11 sixths. All right, so now I have all of these. Now I want to find some equivalent fractions. How do I know 2 fractions are equivalent using my number line? Hopefully you're thinking to yourself, oh, Miss Layton, because they're at the same place on the number line. So I'm going to look for some fractions that are on the same place. I see these ones are. I see 1/3 and 2 sixths are at the same place. I want you to go through and find the rest of the equivalent fractions here. What else are equivalent fractions that they're at the same place on the number line? Hopefully you saw this one, this one, and this one. Wow, that's a lot of equivalent fractions. So let's write some number sentences comparing these. So I could write 0/3 is equivalent to 0 sixths. Or I could write 4/3 is equivalent to how many sixths? I've got to look at my number line. 4/3. When I look down at the sixth, oh, I see it's equivalent to 8 sixths. And what about 4 sixths is equivalent to how many thirds? I can find 4 sixths. It's equivalent to 2 thirds. Perfect. Notice what we did with our numerator and our denominator here. When I doubled my numerator, 4 times 2 is 8, and I also doubled my denominator. 3 times 2 is 6. Same thing. Here I divided by 2. 4 divided by 2 is equal to 2. 6 divided by 2 is equal to 3. So I know that if I got, for example, 4 is equal to 9 sixths, 4/3 is equivalent to 9 sixths, that would not be right because it's not keeping those relationships. Great. So what I want you to do on your own is the same thing, but you're going to compare this time fourths and eighths. So draw a number line from 0 to 2. The top part will be your fourths. The bottom part will be your eighths. And then I want you to find some equivalent fractions using fourths and eighths. For example, 1/4 is equivalent to how many eighths? All right, excellent job, and I hope that made sense about how we can use number lines to show equivalent fractions. See you later. Bye-bye.